मैं आपके साथ जो है चैप्टर नंबर 12 डिस्कस कर रहे और चैप्टर नंबर 12 हमारे पास है सॉफ्टवेयर डेवलपमेंट। तो उस चैप्टर के अंदर से हम ये भी डिस्कस करेंगे कि पेपर पॉइंट ऑफ व्यू से हमारे पास किस तरह के क्वेश्चन आ सकते हैं। तो फर्स्ट ऑफ ऑल, इफ आई एम रेफरिंग टू द सॉफ्टवेयर डेवलपमेंट, in this chapter you are going to learn about the purpose, the types and the stages of the software development life cycle, how you can document your programs, how you can work with different types of errors such as a syntax error, logic error, or a runtime error, and what are different types of maintenance and how you can correct your errors. So this chapter basically starts with the 12.1, and 12.1 is regarding the purpose of a programming development life cycle. A program development life cycle is basically a life cycle of a program. Like if I give you an example of a life cycle of humans, that is like we are born in this world, we go to school, we go to college, we go to university, then we go on to our jobs. So similarly, the development or the life cycle of a software is similar. It's not something like this that overnight a softwares are developed, or it's not even like this that, for example, you just have an idea into your mind and boom, the next day you have your software ready. It's not like this. You have a proper working criteria for that. That, for example, if you want to develop a software, what are going to be some requirements into that? So, in order, if you want to develop a program, first of all, your development has to be in a well-ordered way, in a well-documented form. Like, for example, if someone calls you and asks you that they want to get their software development for their company, so one thing is that you want to have is that you should be making sure that your software documentation is well ordered and clearly documented, because you are right here working as a layman, and you are going to furthermore transmit your knowledge to the developers. So in terms of a program development life cycle, it might be needing a require of alterations. Alterations means repetitions. Like, for example, if you just develop a software and you give it back to your organization, they are going to identify errors, so you need to correct them. So basically, the program development lifecycle is an ongoing process that keeps on going again and again, again and again when you want to work onto your software. Certainly, there are different types of stages that are including in a software development lifecycle. The first stage right here is going to be your analysis. The second stage is going to be design. The third stage is going to be coding. The fourth stage is going to be testing. And the fifth one is your maintenance. These are 5 stages of a program development lifecycle. Now, I'm going to discuss each one of them one by one in detail, so that in case if you have a question into your exam, you can reply to that. So the first thing, before initiating any task or any program, the first thing we do is that we analyze it. Analyze means that before any problem is solved, it firstly needs to be cleared out, so that you should know that what direction you are taking and how you are working onto that. For example, you are having your computer AS level paper 2. So the first thing that you will do after receiving your Cambridge paper into your examination hall is you are going to analyze it. Analyze means you are clearly setting out that what directions, what solutions I can work on, or for example, maybe you are making a mind map of something. Analysis means that what are the requirements that you should fulfill? What are the number of facts that you should work on? What are the things in this paper that you are able to complete, and what are those that you are not able to complete? So this comes into your analysis part. And similarly, if I'm going to take this example on a piece of software, so into your software, I'm going to look forward the feasibility. I'm going to look forward the budget. I'm going to look forward that even if it is clearly defined or not. The second area right here I have is your design part. Now, just after your analysis is completed, you have well documented your program. The second area is your design. Now, in your design, your programmer should be knowing that what should be done. So, design is like an architecture of something. Like you are telling someone that you have to build it this way. Like, for example, if I'm going to give you an example of a house architecture, you could see that you have different rooms, you have your lounge, and you have all of that associated, which tells the labor or the constructor that how you want to construct it. Similarly, if you want to construct a piece of software, the first thing that you need to do is you need to take an analysis. The second thing you need to do is you need to have your analysis, your design part, so that your programmer should know that how you are going on to work onto them. And when it comes to design, there are three different ways where you can design an algorithm. The first way is an structure chart. The second way is an state transition diagrams, and the third way is a pseudocode. The third area in software development lifecycle is coding, and coding is means that when I am writing my program with some sort of any suitable programming language, that programming language could either be Visual Basics, Java, or Python. The fourth stage is testing, and testing is one of the most important one now. Testing perhaps happen like, for example, if you have delivered a piece of software, your client has asked to work onto it, or your client maybe has a different requirement, or if he wants to change that. So testing keeps on going again and again, again and again, because as long as you are going to prepare your software, you're also going to make sure that even if it is working accurately or not, and you are going to do that by working on your testing part. The last area is maintenance, and maintenance is an ongoing process that every software that is created, it is always dealt with some of the problems. Like, for example, there could be some corrections you might want to improve the functionality of the program, or you want to adapt your program to the new world challenges. So maintenance is an ongoing process that keeps on going again and again. So that was basically an overview of a software development lifecycle that I have total number of 5 stages: analysis, design, coding, testing, and maintenance. In terms of examination point of view, they could either ask you that which is the stage which includes creating pseudocode, structure chart, or a structure diagram. So you can say that that is the design part. Like, they can ask you in anything of that, and you might be needing to reply to that stage. In your 12.1.3 now, into your exam, you are provided with different software development models. The first model is a waterfall model, which we are going to discuss. The second is an iterative model, and the third is an rapid application development. Now, when it comes to a waterfall model, for example, if I want you to imagine an any image of a waterfall, like, for example, yes, this one right here. One thing that is similar in our design and this part is that you can see that water is being falling from top to bottom in every type of a waterfall. Similarly, the same concept is being taken right here, that it starts from top and it goes till the bottom. The first area is the analysis, which we have discussed already. The second is your design. The third is your coding. The fourth is your testing. And the fifth is your maintenance one. This is an example of a waterfall model. It is known as waterfall because you can see that it is going from top to bottom. And this basically works with a linear sequential development cycle. Linear means that the first stage is completed and then you move on to the next one. So this is the principle of that it is in linear form. It is well documented, as documentation has to be completed after every stage, and it has a very low customer involvement. And that is only involved at the start and the ending process. That means that your customer is involved in your analysis and in your maintenance. Meanwhile, when you are working with these, your customer is not involved. You have benefits of this as well. The benefits are it is quite easy to use, easy to understand. Stages do not overlap. Each stage has a specific deliverables. And some of the drawbacks are like, for example, it might be difficult to change the requirements at a later stage because your customer is not involved. So there might be some reasons, like, for example, the customer could either say that I have asked this and you have delivered this. So there could be challenges into that. It is not so suitable for programs where the requirements could be changed, and working program is produced later in the life cycle, and it is not suitable for longer and complex projects. So from paper point of view, they could either ask you that what are some stages of a waterfall cycle or what are some principles onto that, you can easily learn one benefit and one drawback. So that's more than enough for you. Or maybe you can go for the two as well. The second area is an iterative model. And when it comes to an iterative model, iterative basically means repetition. That means that I am repeating it again and again. So you can see that this is the first waterfall, this is an extended waterfall, this is further extended waterfall, and this is the final waterfall. That means that now the concept is same, like all of the modules that are being used in a waterfall cycle, but I am repeating it again and again. Like this is the first time, this is the second time, this is the third time until I have the final version. That means I'm repeating it again and again. Now, this is keeps on expanding it again and again, again and again, again and again. The principles of the iterative model is that they are incremental, which means that every time they have to be incremented by one, every time the cycle is completed. Your working programs are produced as a part of the system at every iteration. That means that at every iteration, at every step, you are producing something, and it requires a high level of customer involvement, because as part of the system can be shows to the customer after every iteration. Like for example, you ask me to create a software based on examination system. The day I complete that, I'm going to show it back to you. So you are again going to give me some changes, then I'm going to change it back again. So this keeps on going on again and again. What are the benefits of that? It is developed quickly, it is easier to test and debug, it is more flexible, and customer is involved. So customer is quite satisfying because you are showing that piece of software again and again to the customer. Whereas when it comes to the drawbacks, one thing is that it is not suitable for short and simple projects. It needs a very good level of planning, and it is quite time consuming as well because it is broken down into pieces and it is again and again developed each time your customer requires. This is the second model. The third model you have is named as RAD, Rapid Application Development. RAD. It stands for Rapid Application Development, and Rapid Application Development works in organizations or companies where they want the piece of software to be developed right instantly. Like for example, I am a big company, and this company wants a piece of software, but it wants it instantly. So what I'm going to do, there is going to be a project manager, and that is going to divide the software into number of departments, and then that person is going to hire three teams or more than that, and he is going to allocate each team a piece of module or a piece of function so that they can work onto that. So similarly, you can say that if simultaneously, if I ask or if I add more number of people to work on different modules of the same project, so it is going to be much quicker, it is going to be much faster, and it is going to be much efficient. Other than that, if I ask a limited number of people to work on a project, like first of all, they are going to complete that and then they are going to move on to the next part. So that's quite time consuming as well. So this development cycle works in a parallel way, and some of the principle of that is that it needs minimal planning. It reuses previously written codes where possible. It makes use of automation as well. It has a high customer involvement as customers can see the prototypes you are developing. The benefits of that is that it reduces the time. It is very faster. It has a rapid it has a rapid customer response. Like for example, I completed the first module. I called my customer like, okay, so I have done that. You can tell me the next changes. And so similarly, many teams are working all together. So this is a pretty much faster way. It is quite flexible as well, and many of the systems can be developed side by side. Modification can be quite easy. However, the drawbacks of that are that system under development needs to be modular as well. Modular means that they have to be broken down into separate modules, separate categories, so that each team can work onto that. They also need a team of strong, skilled developers, because there might be not scenarios like, for example, team A is performing efficient or team B is not, or team C. So there could be quite comparisons into their work, or there could be quite challenges and difficulties as them. Hence, they all have to be skilled developers. Third part is that it is not suitable for the short and simple projects as well. So I hope you do not have any queries in 12.1. In 12.2, now I am going to specifically refer to the program designs, and program designs, you know it already that I have a structure chart, I have state transition diagrams. So what is basically a purpose of a structure chart? It is basically an example of a modeling tool that you can use in your program design to decompose or break down a problem into many number of parts or into many number of subtasks. It shows you an hierarchy. Do you understand what is meant by hierarchy? Hierarchy means that which one is higher in order or which one should be completed first. And a structure chart shows that how they are connecting with each other, how they are interacting with each other. They are basically provided to you with some set of boxes or arrows to show that how they are work with that. And you have already completed the question of the structure chart, so it should be quite understandable to you as well. It also shows selection, decision making as well, number of repetitions as well. We have state transition diagrams into our exam as well. And this is basically an example of a mathematical module that shows you conditions needed for an event, and state the transition diagram shows conditions needed for an event or event that will cause a transition of condition to occur, that you can simply illustrate your number of outputs, your number of inputs as well. They are constructed by using circles, by using interconnected arrows, by using labels, by using conditions. So you can like for example, this is the one. Like you can show that what is going to be the next state, what is your input value, what is your output value, and the questions you have already completed into your past papers regarding a state transition diagram works like this. Like you can show that what is the current state, what is going to be the next state, what are the events or the conditions that are occurring right here. Now, 12.3, which is program testing and maintenance. This is one of the most important areas that is asked again and again into your exam, and we are going to discuss this. Just after my class is completed, you can also review to this page number 448, or let me send the screenshot to you so you can revise from here, since these all are quite important for you. They might ask any sort of testing method into your exam. Now, moving on, what are some of the ways that I can avoid and expose faults into the program? So programs are definitely written by humans and humans make mistakes. The aim is to avoid mistakes, and before it goes live or anyone finds out. Faults can occur in the design of your program. Faults can even avoid your program to start as well. They can be solved by having your piece of program into a well documented form, or into where you have your design stages. Like for example, if I ask you that there is an error into my software, so what you are going to refer, first of all, you are going to refer the design of that program. The design could be in a structure chart, in a pseudocode, in a state transition diagram. So you would know that how those files and parameters are being handled. So faults and bugs can be exposed at your testing stage. Just remember one thing, that this area is purely linked to your testing stage, and through testing we correct the existing faults into a program. The first test that I'm going to discuss is your syntax error. And syntax error is the same as that what you often face into your calculators as well. Syntax errors are basically errors in the grammar of a source program. For example, many syntax error, like for example, right here, you can see that value 1 is 20, value 2 is 30. So it should be adding total equals to value 1 plus value 2. But the spelling is wrong. And if someone writes like this, it is not going to cater the same value of whatever is in your value 2. This is not going to be catered. So this is an example of a syntax error where you have problem into the grammar of your source program, such as misspelling. So this needs to be checked. This is the first error, which is syntax error. The second error is a logic error. Logic errors are basically occurred in the logic of your program, meaning that the program does not know what to do and what it is supposed to do. Like, for example, right here, you can see that y should have been incremented, but the value in x have been used incorrectly. That is a logic error. For example, if direction is n, then y equals to x plus 1. If If direction is s, y equals to y minus 1, e x plus 1. So this is supposed to be incremented because the value in x has been ordered incorrectly. So wherever you have some errors into the logic of that, such as multiplication, addition, division. For example, if you have added your identifiers wrong, so this is going to be a logic error. The third one is a runtime error, and a runtime error basically means that whenever your program is being executed or it is being running and it is halt unexpectedly. Halt means it is stopped. Like for example, you might face an example of an interrupt. It is stopped by any sort of error. So these types of errors that occur while you are executing your program, they are going to be considered as your runtime errors. These are three types of error that are included in your syllabus, such as your runtime, logic, and syntax error. The next area is your testing, and programs definitely needs to be tested again and again before they are released. Testing begins from the moment they are written. You can have different testing strategies to test them. So you can even prepare a test plan as well, draw out your conclusions. The first testing that we are going to discuss is a dry run, and a dry run is an example. Like for example, if this is a code and you are requested to dry run that, so dry run means that you are actually going to run that code and you are going to create a trace table based on that. Like for example, you are going to run this procedure case of sign. If you are pressing the plus sign, what is the value? If you are pressing the minus sign, what is the value? If you are pressing the multiply sign, what is the value? So dry run means that you are actually running that software and creating a trace table, so that in this you can basically found that what are the values that you should not expect. So this is a dry run. The second one is a walkthrough, and a walkthrough is basically a formalized version of a dry run. A dry run is that, for example, you took a piece of paper and a pencil and you start chalking out down that what should be the error. Whereas when you go through a walkthrough, this is a formalized version, because this is where another member of the team independently runs the code. During the program development and testing, each module is set out. For example, this is a formalized one. For example, to test the positive condition, to ensure that positive condition works as expected. So you have your test data as well. So against your test data, you are checking that if you have that exact expected outcome or not. And I hope that all of you know regarding the test data. I have three types of test data: normal data, abnormal data. We have this right here. We have three types of data. Yes. Um, yes. One is a normal data. A normal data is one. A normal data is one that says that your value should be accepted, and abnormal data is one that should be rejected. And an extreme data is the one that is at the limits of that accepted program. Similarly, we have boundary data as well. Boundary data means that your data is on at a limit, it but it is just outside the limit of that rejected program. So I'm repeating it again. A normal test data is a test data that should be accepted by a program. And abnormal data means that is rejected. And extreme data means that it is on its extreme end, but it is accepted. Boundary means that this is a test data that is on the limit of that accepted program, but it is outside the limit that is of it is a rejected one. This is the definition. You can refer to that as well. I have sent you on the group. These examples are right given here as well. Abnormal means that the value that is being accepted. Abnormal means that that should be rejected. Extreme is that the limit. For example, when testing a validation rule such as a number that is greater than 12 and less than 32, you can just read it out. That's quite simple. You will easily understand it. The next area we are needing to discuss is that some types of testing that we need to use in your exam, you are quite asked for them. The first area is a white box testing. So in terms of white box testing, this is a detailed testing of how each procedure works. This involves testing every logic and every structure of a program module. For example, you are provided with a structure chart and you are requested to do a white box testing. So in your white box testing, you will be requested to completely test each and every structure, logic, and module of your program. The second area you have right here is a black box testing. And black box testing means that testing a module's input and output, like certainly what is the value that is being inputted or what is the value that is generating an output. The third area is your integration testing, and integration testing is the one which is focused on separately written modules. Like, for example, I'll give you an example of an alarm app. An alarm app have different modules like alarm on, alarm off, ring alarm. So when separately written modules, when you are testing them all together into one way, into integrating them into a one software, this is to be known as an integration testing. In integration testing, you create basically stubs. Stubs are to be referred to as small modules or small module or program modules. Like they can be created for dummy purposes and you can test them to see that if your program is working properly or not. Alpha testing is also used, and alpha testing is used when your program is completed or nearly completed. But alpha testing is only used by in-house development team, which means that it is only used by the number of people who have created that software, which is only going to be tested by them. Then when you send this software to the public or to a small group of users and you have released that, so this is a beta testing. Beta testing means that your software is completed and you have release it to a small group of people and you have requested to test them. The third area is your acceptance test, and an acceptance test is used for completed program to prove that customer that it works as required in the environment in which it will be used. Acceptance test means that you are proving to your customer that it is working as per your required in the environment. Programming maintenance is also included, and you have three types of programming maintenance. Programming maintenance means to maintain your software so that it does not get old or perhaps the modern techniques do not make your program obsolete. You have three different types of program maintenance. The first one is a corrective one. Corrective means that you are correcting the existing errors that appear during the usage of your program. For example, if there is a runtime error and you are going to fix that, this is going to be corrective maintenance because you are correcting the error. Second one is your perfective maintenance, and in your perfective maintenance, you are basically improving the performance of your program. For example, improving the speed, improving the response of that. You are making it even more perfect. The third one is your adaptive maintenance, and adaptive maintenance means that you are adapting it or you are changing it to the new world needs, to your new customer requirements. Like you are altering it so that it can perform more number of tasks. Like for example, if your user wishes for voice recognition, you can definitely go for adaptive maintenance.